There are two main ways of creating a user interface in an iOS app. There's the traditional UIKit, or there's the new Swift UI. Swift UI is the cool new way of creating user interfaces using Swift in an iOS app, and I'm going to make videos on Swift UI in the future, but right now it's still a little bit young and a little bit limited to be using just Swift UI, so to be an iOS developer you still have to know how to use UIKit. In this video I'm going to go over the basics of UIKit and show you how to use UIViews in your iOS application from Swift and from storyboards. When we create a new single view application in Xcode, we have the option of choosing either storyboards or Swift UI. And when we select storyboards, we're basically saying that we're going to use UIKit to set up our user interface in this application. Now, Swift UI and UIKit can be used together in the same app, but for now we're just going to focus on UIKit. When we choose to use storyboards for our application, our first screen is represented by this view controller, which is a subclass of UIView controller. And the UI here suggests that this is part of the UIKit framework. UIKit is the framework in iOS that we can use to build our user interfaces, handle user input like touch events, handle animations on things like UIViews, and tons of other things. Right now, I want to focus on how we can use UIViews in our application. Every view controller has a UIView that we can access through the view property, and this is the thing that we see when we launch our application. We don't see the view controller, we see the view controller's view. And this has properties that we can modify that will modify how the view appears to us when we run our app. So one of those properties is the background color property. That is a type of UI color, and keep looking out for this UI prefix again because it means that it's part of the UIKit framework. Now, UI colors are the base class that we use to represent colors in UIKit, and we can construct a UI color in many different ways. One of the most popular would be to use RGB values, like this, or we can use one of the default colors that can be accessed through the UI colors static properties. So there's a few colors like blue, or purple, or even magenta. Or in Xcode we can use the color literal feature, where if we type the word color and select color literal, we can just literally select a color from a color palette, and this will create a UI color object for us and hand it to the view as its background color. And now if I run this application, all right, we should see the initial view load and it should be this green color. UIViews are the most fundamental building block that we use in UIKit. When we build our UIs, everything's going to either be a UIView or a subclass of a UIView. Things like buttons, labels, ImageViews, they're all subclasses of a UIView. But before we get into all that, let's just look at what a UIView is. I can create a new view with the UIView initializer, and views in the most basic sense are just rectangular regions on the screen. They have an X position, a Y position, a width, and a height. So I've created this view, but right now it doesn't have a width or a height. So in order to actually see this on the screen, I'm going to have to set those values. Every view has a property called frame that is a CG rect that can hold an X value, a Y value, a width, and a height, just like I'm doing here. And because every UI view needs a frame in order to be seen, there's a convenience initializer that we can use on the UI view where we can just pass in the frame. And now this view will have an X position of 50, a Y position of 50, a width of 200, and a height of 100. But if I run the application, we're still not going to see it on the screen. In order to actually see the view, we're going to have to add it as a subview to another visible view. So in this case, the only view we can currently see is the view from the view controller. So I can call a method on that called add subview, and then pass it a different view. And if a view exists as a subview of this view, I'll be able to see it. And I said view a lot there. And there we go. So that's now added to the view hierarchy. So this is similar to how the view hierarchy in Android works or how the DOM in a web browser works. you can create these views or these nodes, but you won't actually see them until they're part of the view tree. So you need to add them as a subview to another view, and there's really no limit on how many subviews you can add, and every view can have its own subviews, but we just end up adding views to other views using this add subview method. So to demonstrate that, let's create another view. And I'm going to set its background color to be blue, and I'm going to add it as a subview, not to the main view, but to my view. So the main green view contains the magenta view, and the magenta view contains the blue view as a subview of that view. And this is kind of a little bit of weird behavior right here. By default, a parent view won't cut off a child view's appearance. So the width of the blue view extends outside the magenta view, but by default, the magenta view is not going to cut that off. It's still going to allow the view to be seen. And if we want to stop that from happening, if we want to clip the blue view there, we can add a property to the magenta view that says clip to bounds equals true. And if we rerun this, the blue view won't be able to extend outside of the bounds of the magenta view. Now, the geometry in an iOS app works a little bit differently to some other platforms. So if you remember back to high school geometry, the coordinate system starts in the bottom left corner at 0, 0, and increases its x and y axis towards the top right. And this is how the coordinate system works in something like a Mac OS app. But in an iOS app, the coordinate system starts in the top left, x increases as you go right, but y increases as you go down. So it's flipped a little bit, but this helps out when we want to create iOS apps, because it turns out having 0, 0 at the top left is a more natural way of thinking when we're creating iOS apps, because our content starts at the top and goes all the way down the screen and maybe even goes through the bottom of the screen, and we have to scroll to see the rest of the content. So in this case, the x and y value of the magenta square are both 50, so this is sitting 50 points to the left and 50 points down. And this isn't pixels in the traditional like hardware pixel sense, this is points. So no matter if I'm dealing with an original iPhone or a Retina iPhone or the new crazy amount of pixels in the new iPhones, it's always going to appear to be in the same place. And then this blue square also has 50x and 50y, but that's relative to its super view. So the blue square appears 50 pixels inset from the magenta view, not from the view controller's view. And then the width and height behave as you'd expect. They both have a width of 200 and a height of 100. There are many properties on a UI view that you can change, but some of the most common that you might want to use would be the alpha. And this will change how transparent the view is. So I set the alpha of the magenta view to be 0.5, which means that it and all of its subviews will now have 50% transparency. And it's important to know that if I set this property on a super view, it will affect all of its subviews. I can also completely hide a view by setting its isHidden property to true. And this can be handy because the view now still exists in the view hierarchy. So the blue view is still there, it's just invisible. So instead of having to remove it from the super view and then add it back in later, I can just hide it temporarily if I need to. Every view also has a frame property, a bounds property, and a center property. And we use these when we want to read where a view is positioned, but also when we want to set where a view is positioned. So I initially set the location and size of the view in the initializer right here, but I can modify that at any point in time. So if I want to modify the entire location and size of the view, I can set its frame to be something different. But if I just want to maybe modify the position, I could set its center position. And I think the easiest way to talk about these is to first see what their values are. So if I print the frame, bounds, and center, we'll see that the frame has an x and y 50, a width of 200, and a height of 100, and this is exactly what I set the frame to be, so no surprises there. The center is 150, it has an x of 150 and a y of 100, and this is because it's telling us where the center point of this view is relative to the super view, so that's right around there. Then the bounds gives us 0, 0, and the width and height, because the bounds is telling us where the view is within its own coordinate system. Now, most of the time this will be 0, 0, but not always, and I'll leave a link in the description to more information about this if you want to find out more about the difference between frame and bounds. So that's half a video. My kid woke up from her nap early, so now it's nighttime. I'm going to set the alpha and hidden properties back to their default values because I want to show you another interesting property that every view has, and that's the transform property. And the type of this property is a CG-affine transform, which is a struct that represents a 3x3 transform matrix. So if you're into linear algebra, that's pretty interesting and you can modify those values directly. If you're not into linear algebra like most people, then you can create a struct using one of the more user-friendly interfaces. So for example, if I wanted to rotate a view, I can create a transform struct using this initializer and pass in a radian value here. Now because it's in radians, 2 pi would be a full 360-degree turn. So I just want to get it turned slightly just so we can see like a slight angle there. So I'm going to use CG float dot pi divided by 4, and that'll give us a 45-degree angle. There we go. And notice that even though we're talking about UIKit here, a lot of these things have the prefix CG instead of UI, and that refers to the core graphics framework, which is slightly lower level than UIKit. And I'm not going to go into core graphics in this video, but it's worth noting that if we want to take more control of our views and our UI, we can learn about this core graphics framework as well, and it gives us way more control, way more power over everything that's seen on the screen. And I'll include a link in this video if you want to learn more about core graphics. So this is what it's like working directly with UIViews, but a lot of the time we want to work with subclasses of UIViews that give us more added behavior. So for example, if I want to display text on the screen, I'm going to use a UILabel. So with minimal effort, I can display pretty much any text I want using this UILabel class, and it's a subclass of UIView. So it acts in the same way in a lot of ways, like I can still use this frame constructor and pass in a CG rect, but it also has special properties that only apply to a label, things like text and text alignment. But like I said, it is still a UIView, so I can do things like transform it in the exact same way I would transform any UI view. And to quickly learn more about these classes in Xcode, we can command click on the class like this, click on jump to definition, and Xcode will actually take us to the interface for UILabel in this case. And we can see that UILabel is a class that inherits from UIView and conforms to some protocols, and here are all the properties that we can access. So text, font, text color, shadow color. So this can be a good way of checking out how some of these classes work without having to go to the official documentation or search through the internet for anything. Another subclass of UIView that we'll end up using a lot is the ImageView. Now, as the name suggests, ImageView is a view that will display an image, and we give it an image using its image property that's expecting an instance of UIImage, which is another class in UIKit that knows how to deal with the most common types of images. So we can create a new UIImage object from an image file or from data that we've downloaded over a network, and then we can hand that UIImage object to the ImageView, and the ImageView will display it for us. So I've just downloaded an image that I want to use in this iOS project. Here's the image. Now the easiest way to get this into the project in a way that UIImage can see it is to use this assets.xc assets folder. So if I open this, I can just drag any image into here, and I can rename it in the side here, whatever I want it to be. I'm just gonna maybe call it photo 1. And now all I have to do is pass the UIImage the name photo 1. And in the assets.exe assets, we can store any number of images, and we can also store images for different screen types. So the 1x is for old iPhones before Retina displays, 2x is for the Retina displays, and 3x is for the really high-res new iPhones. We don't have to supply an image for each of those if we don't want to, it will just use the 1x, but it can be a really easy way of just supplying all the different resolution images that will then get used in the iOS app. So now UIImage is going to load that image file. We're going to hand the UI image over to the image view, and that's going to display it on the screen. And there we can see the image view display just like the other views. The image is a little bit squashed though, so I'm just going to change that. So just by changing one of the properties, it will change how it actually renders that image. So ImageView, again, just a subclass of UIView, and we can jump to the interface here and see that it's a subclass of UIView, and it has a bunch of properties that deal with images. Some of the most important is the image property itself and the content mode, which defines how it's actually going to be drawn to the screen. And since iOS 13, we actually have system images built in called symbols, and we can use those in a very similar way. Except instead of using the named initializer, we use system name. And now this is going to pick from any of the SF symbols that are in iOS and just display that on the screen. And these are types of symbols that you might see in a lot of applications. So it can be helpful when you need it, for example, maybe a button or something, to use these built-in images instead of always having to import your own. UIImage and UILabel are very simple foundational views that we use all the time in iOS. But UIKit also has much more complex views that might even be composed of labels and images. So a button is a more complex view, and if we check out the interface, we'll be able to see amongst all of these properties, it has a title label, which is a UI label, and it also has an image view, which is a type UI image view. And that's because every time we use one of those buttons in our iOS apps, it can have a bit of text as the title, or it can have an image, or it could even have both. So we can create views that are composed of other views to give us the behavior we need. Now, I'm not going to create and use a button here. Buttons are controls, so they're more complex to use, and I'm going to go over how to use controls in another video. But for now, I just want you to see that views can be very simple, or they can get quite complex, and you can compose views from other views, which is a very common thing to do. So right now, I've been doing everything in code, and I'm just going to delete all of this for now, because we can do most of our setup for our view without writing a single line of code, just by using a storyboard file. So if I click the plus button at the top here, I can select from this list of views. So if I want a label, I can just drop a label in here. And if I want an image view, I can drop that in. And again, I can select one of the system images, or I can select that photo that I have. There we go. And I can just drag in ordinary UI views if I just want a rectangle, maybe a different color, and I could place views inside other views, but I get to do it all visually and write much less setup code. So this can be a quite nice way of setting up your initial view structure. So if I select one of these views and go up to the top right here and select the size inspector, I can change the X, Y, width and height of any of these views. And to the left of that, there's the attributes inspector. And this is where I can change most of those default properties. So for a view, that might be changing the background color. And for a label, that might be changing the font size, the actual text, maybe the alignment and things like that. And then over to the right here, this is where we can see any references to IB outlets. So if I want to add any behavior to these views, or even manipulate one of the properties that I can't here. So for example, I can't rotate this view from Interface Builder. There's no transform property here. I need to do all of those things from Swift, so I need to create an outlet. So if I bring up the assistant editor here and I right click from, I'm going to do the GreenView, I'm going to right click from the GreenView into View Controller, drag and drop, I can create a new IB outlet to that view, and I'm just going to call this GreenView. And now I can modify this from my code. Notice that the outlet is a force unwrapped optional, meaning it's an optional that's always going to be force unwrapped. And this is because every property in an object must have a value by the time the object is initialized. And in this view controller, the view controller is going to get initialized before all the views appear on the screen and everything's set up in the storyboard. So at the time that the view controller is initialized, the GreenView might not exist. So from the initialization time to the time when viewDidLoad gets called, GreenView may or may not exist. We don't know. But as soon as viewDidLoad gets called, as soon as this happens, GreenView is guaranteed to have a value. So properties that are IB outlets are going to be force unwrapped optionals because they won't have a value when the class, in this case the view controller, is initialized, but they will have a value by the time we're going to use it. We're not going to try using it until viewDidLoad. So it's weird because it seems unsafe, but in circumstances like this, we're not going to use it until it has a value anyway. So it's kind of okay. I'm going to go back to the storyboard file now because I want to point out one big mistake that new iOS developers make, and that is to try refactoring the name of an outlet. And in this case, maybe I don't want to call this GreenView anymore. Maybe I want to call this, I don't know, rectangle view. That's fine, right? So you might be tempted to just change the name of the property directly, and you can do a find and replace in the view controller and change everywhere you've used it. And this seems to be working fine, but now if I run the application, it crashes, and the error message is not the most helpful. Terminating app, reason, user interface view controller, set value for undefined key, is not key value, coding compliant for the key GreenView. So there's not a lot of information here, not a lot of helpful information anyway. It is talking about GreenView, and you've already changed that to rectangle view, so that could be a little bit confusing too. Basically, if I select the view, the GreenView in this case, and head over to the connections inspector over at the right here, I can see that it is still thinking that it's connected to a GreenView property. So when the app loads, it tries to connect itself to the view controller as GreenView, but view controller thinks its name is rectangle view, and the app just crashes and nothing works. So in this case, the correct thing to do is to just delete that property from there, and then you can just redrag to the new property, just like that. Highlighted, redrag it in. So if you ever get that error message, just delete the old connection and create a new connection. A much better way, if you ever need to refactor any of these things, is to use the refactor feature in Xcode. So if I go right-click, refactor, rename, I'll get this window, and then I could change this even back to GreenView if I wanted, and it's going to change it here and everywhere else in my code that it finds it, including the storyboard outlet. So if I rename it that way, it's going to work, and then I can rerun it. So make sure you don't make that mistake. That's the basics of UIKit and how to use UIViews in an iOS app. In the next video, I'm going to go over how to use UI controls like buttons and switches. So stay tuned for that video and more videos on iOS development.